So the question is, can we see light? This question I asked to many students, BTech students, MTech students, and I have got all kinds of answers. So let me clarify whether we can see the light or not. My name is Dr. Prakash Somni. I belong to Center for Grand Challenges and Green Technologies, Applied Science Innovations Private Limited, Pune 411041, Maharashtra, India. So light, as we know, this PPT analyzes the general properties of light. Light is a form of energy, or energy is transported through light. Both the ways it can be, this sentence can be true. But if we see light, it has a dual nature. It belongs to particle nature as well as wave nature. Particle nature, we always talk about the concept of photon, whereas the wave nature, we talk about the concept of electromagnetic waves. And these two properties, particle nature and wave nature, they are shown in different experiments. There is no single experiment that shows both the particle nature and the wave nature of light. Now light as a photon, this type of behavior, uh, behavior is shown in the experiments like Compton effect, photoelectric effect, and so on. Whereas the light as electromagnetic nature, wave nature, is displayed in experiments like interference, diffraction, polarization, and so on. There is no single experiment in which both the nature of light, that is particle nature, and the wave nature, photon concept and electromagnetic waves, are applicable simultaneously. Light has the highest speed. Light travels with the highest speed of 3 into 10 to the power 8 meter per seconds, which is unattainable to any material particle like electron, proton, neutron, and so on. We cannot accelerate any particle practically so that it travels with the speed of light. Then all kinds of different physics comes into picture. So any particle, material particle, cannot have a velocity, speed that is equivalent to or greater than the speed of light. Now, one more interesting property of light is that it doesn't require any medium to travel. As you know, the many different kinds of waves, such as sound wave, requires a medium for travel. The waves which are produced on the water surface, water is the medium through which the wave travels. But in case of light, it doesn't require any medium. It can travel through even vacuum also and doesn't require any medium to travel. Now, under certain circumstances, under certain conditions, experimental conditions, the speed of light can be altered. It can be slowed down. There is no experimental evidence, we can say, where the speed of light can be increased, but definitely the speed of light can be slowed down under certain experimental conditions. It has been proved also. Now, this is the electromagnetic spectrum, that is, we can say, the light spectrum, and it consists of, we can classify that into different categories. On the extreme left hand side there are gamma rays and X-rays, whereas on the right hand side there are radio waves. Gamma rays and X-rays, they have the shorter wavelengths. This is the wavelength lambda that is shown here in nanometer region. Now the X-rays and gamma rays, they have the shortest wavelengths and they are useful for various applications like in medical field also. Then comes the UV light, ultraviolet light, and visible portion. Visible portion is very small, belonging to 400 nanometer to 700 nanometer. Sometimes it is taken also as 800 nanometer. Then after 800 nanometer, it is counted as IR radiation, infrared radiation, up to 10 to the power minus 4 or even more. And then comes the microwaves and radio waves. There are short wavelengths radio waves which we use in the which we use as radio frequencies and for listening to radios and so on. This is FM and AM type of waves which are shown here. and longer radio waves which are having wavelength much higher than the usual radio waves shown in this region. Now you might be knowing that India is having a very good research center near Pune, that is a telescope which is built to detect the radio waves of very long wavelengths, that is the GMRT, Giant Matter Radio Telescope. So it detects the radio waves of wavelengths more than 1 meter long. So such type of waves also do exist, and it requires sophisticated technique, sophisticated um, experimental technique for detection, and then for its understanding and usefulness. So this particular spectrum, if you see, this is all can be considered as a light spectrum or electromagnetic wave spectrum, and it consists of different regions that we have named it as X-rays, gamma rays, UV light, visible light, IR, microwaves, and radio waves, and so on. Now these are the different types of atomic and molecular transitions shown here, which are giving rise to this kind of light. So gamma rays, they are coming mainly from nuclear transitions. X-rays, they are coming from core level electrons transitions. Ultraviolet light, valence electron transitions. Visible light, valence electron transition. Infrared, it comes from molecular vibrations. Microwaves, they comes from molecular rotations or electronic spin, and radio waves, they come from nuclear spin. Now the important question that we can ask ourselves is, can we see the light? The simple answer to this question is no, we cannot see any kind of light, including visible light. So even the visible light that is corresponding to the wavelength range from 400 nanometer to 800 nanometer, it's just the name given as visible light. It's not the light which is visible to human beings. Any kind of light from the electromagnetic spectrum is not visible to human beings. Uh, the name visible light is given as it produces sensation on the retina of our eye and useful for vision purpose for the human beings. That's why the name given as visible light, nothing else. But we cannot see any kind of light, whether it is a visible light or gamma rays, X-rays, microwaves, radio waves, ultraviolet light, visible light. We cannot see any kind of light. Now if we can see light, probably we cannot see the objects. Look at here, there is an observer here, and there is a key here, that is the object, and you can see the shadow also in this picture, and it means that the object is illuminated, there is a light present, but the observer is able to see the object and not the light. The observer is able to see the object and not the light, even though light is present in between the observer and the object. So it's because there is always light in between us and the object, and if we can see the object, probably we cannot see the light, and if we can see the light, probably we cannot see the object, because there is in between the object and the observer, there is always a light present. So what we can see is its after effect, that is, when the light interacts with the object and enters into the eye, when the light gets reflected from this object and enters into the eye of the observer, we can see the after effect. So all types of light from the electromagnetic spectrum are invisible to human beings and they cannot be seen. So the conclusion is, can we see the light? No, we cannot see any kind of light from the electromagnetic spectrum, including so-called visible light. What we can see is its after effect, after it interacts with the object and enters into our eye. That's what it creates sensation, and that's what we can see the different objects, but we cannot see the light. Any kind of light we cannot see, whether it is X-rays, gamma rays, ultraviolet light, visible light, microwaves, radio waves, and so on. So we cannot see light. Thank you very much.